All right, class, so this is a ALEKS topic that's called Estimating a Phase Transition Temperature from Standard Thermodynamic Data, and that thermodynamic data we're going to find in our ALEKS data tab. So I'll show you what that looks like in just a second. And this is sort of a tricky problem, but I think it's a great problem, and it brings together a lot of different concepts. So it says calculate the boiling point of ammonia, and then round your answer to the nearest degree. So it doesn't give us very much information, and obviously this is just something we could look up, but this is sort of, again, bringing together a lot of different information. And sort of the starting point that I would say that we need to think about would be the actual chemical reaction that represents the boiling of ammonia. So that NH3 liquid turning into NH3 gas, that's sort of what we're talking about. And then this thermodynamic information, what that's talking about is the delta H and the delta S information. So that's our normal thermodynamic information. Also, we're going to have a delta G that's associated with this. So since this is an equilibrium process, so at a phase change temperature, we're going to have an equilibrium process between the liquid and the gas. That's our boiling point. And that's what we talked about in class the other day. This delta G equation, that's going to equal 0. So when delta G is at equilibrium, when our chemical reaction is at equilibrium, that means that the delta G, the change, is going to be 0. So we can apply this equation here to our boiling point sort of reaction that we're talking about. So I could rearrange this where I would have then delta H equals T delta S, and then the temperature at that phase change, when that happens, is going to equal delta H over delta S. So this is sort of the key piece for this type of problem. So now what I need to do is figure out what that delta H and delta S information is. So if you look at this data tab, what you'll find is delta H information and delta S information for this NH3 gas and NH3 liquid. And since I'm talking about this chemical reaction right here, I can calculate what the delta H and delta S of this chemical reaction is from this thermodynamic data. It's just going to be the sum of the products minus the sum of the reactions, or just in this case, the enthalpy of NH3 gas minus the enthalpy of NH3 liquid. That'll tell me the enthalpy of this reaction. I can do the same thing for the delta S. So I'll show you what that looks like. So I'll just put this over here, using this table for NH3 liquid and NH3 gas, just sort of highlight that for us. For the delta H, that's going to equal the sum, right, or really just this NH3 gas minus 46.19 minus a minus 69.54. So that's my enthalpy of my gas minus my enthalpy of my liquid. This is going to equal a positive 23.35. This should make sense. We'd expect that to be an endothermic process, right? To go from liquid to gas, we have to put energy in. So this is my enthalpy. For delta S, that's going to equal 192.5, again, minus 95.09, and that equals 97.41. Remember that this is joules and this is kilojoules per mole. So this is joules per mole times Kelvin, and this is kilojoules per mole. So I'm going to have to, convert this to kilojoules, most likely would be the easiest thing. And then again, does this make sense, right? Do we expect a positive entropy for this as we go from liquid to gas? Yeah, that does make sense. So if I convert this to kilojoules, that's 0.09741 kilojoules over moles times Kelvin. And now I can basically just plug these values in to my equation that I have up here, sort of at that equilibrium state. The delta G will equal 0, therefore this should be true, and I can solve for that temperature. So that would just going to be 23.35 divided by 0.09741, and that equals 239.7 Kelvin. So keep in mind that this value is in Kelvin. So this is my estimated boiling point based off of this thermodynamic data. I can convert that into Celsius. So degrees Celsius is minus 33 degrees Celsius. And that's what I would plug in as my final answer. So round your answer to the nearest degree, and it wants it in degrees Celsius, and that's pretty much it. So I think this is a really great problem. We have to first understand what the chemical reaction we're talking about is, then apply this delta G information, right, to figure out what our enthalpy and entropy are for this system, and then we can solve essentially for what the estimated temperature of boiling point would be you know, based off of this thermodynamic data. If you actually look it up, you get pretty much the same answer. I think on Google or Wikipedia it says minus 33.4. So a really good estimate, right, of the actual boiling point. So should work. All right.